I've already connected the power supply to the potentiometer, and we're going to move on from there. So I'm going to take a lead connecting the center of my potentiometer to the positive terminal of my ammeter, like that. Then I'll take a lead from the negative terminal, or the common, of my ammeter and connect that to the positive terminal of my voltmeter. I'll then take another lead, connect that to the common port of the voltmeter, and that will go back to my potentiometer. The final thing to do is to connect the Zener diode. So this is a reverse bias diode. So what we need to do is to connect this to our voltmeter. So I'm going to be connecting the positive terminal of the voltmeter to the cathode of the diode. And I will connect the common terminal to the anode. Okay, so I've turned the dial on the potentiometer all the way counterclockwise, and now I'm going to switch on my ammeter again to the DC scale, and also my voltmeter. So now I can switch on the power supply, and we want that at about 10 volts. So now what I'm going to do is I'm going to increase the voltage and look at the corresponding current. So you can see that even though the voltage is increasing, we are getting a current reading of 0 amps, but that is to be expected at low voltages. So you can see that once we get to around 5.4 volts, we register a current reading. So what you can do is simply record the voltage and the corresponding current. So 5.627 volts and 6 milliamps. And we're just going to continue increasing the voltage and recording the corresponding current. You'll notice that now, as we increase the voltage, even slightly, the current begins to increase rapidly. So be careful when doing this part of the experiment, because an excessive current will damage the diode. So we can continue taking our measurements, but once we've taken it, we want to quickly just drop back the voltage a bit so as not to damage the diode. Once you've collected sufficient data, you've concluded this section of the experiment.